Hey folks, 9.3, estimating a population standard deviation. Make sure you grab the worksheet. There's a link to it right there. It's also in files. So I keep drawing this picture. There's a population of interest. Can't talk to everyone or everything in the population, so we take a subset of the population. We look at a sample. Hopefully there's no bias. So we can look at certain things within the sample. Remember, numerical descriptions of a sample are called statistics. So if we look at the sample proportion, p hat, we're hoping that p hat is a good approximation to p. And if we look at the sample mean, say x bar, we're hoping that that is a good approximation to mu. So mu and p describe the population. These are the parameters. When we look at a sample, we can also get a sample standard deviation S, and hopefully that is a good estimate of our population standard deviation, sigma. So look at that little worksheet I gave you on page 1 and just make sure that we're cool with the vocab. S, sample standard deviation. S squared is called sample variance. Sigma is our population standard deviation. Sigma squared is our population variance. And then they give us some formulas. It looks scary at first, but it's no big deal. Also up top it says no magical calculator shortcut. Okay, so if we're looking at our formulas, you'll see that if we want a confidence interval for population proportion P, based on our P hat, we would use the 1 prop Z int. If we want a confidence interval for the true population mean mu, we would use a T interval with X bar and S using statistics from our sample to create a confidence interval for mu. So if we're trying to create a confidence interval for sigma, or sigma squared, basically the same thing, just square it, we're going to base it upon our sample standard deviation S. Okay, so it's completely analogous to what we were doing before. We're making a confidence interval. And just keep in mind, we don't have a 1 prop Z int or T interval like function on our calculator, so we're going to have to actually use those formulas. So you'll see next to 1 prop Z int and T interval, I just wrote the formulas. You'll see that the 1 prop Z int is that P hat plus or minus Z alpha over 2, P hat 1 minus P hat all over N. See how it can be written as P is between P hat minus that margin of error and P hat plus that margin of error, where margin of error is just the Z alpha over 2, big square root P hat 1 minus P hat all over N. Whew. Okay, so let us do problem number 1. So first things first, I just want to make sure that we know how to read our chi-square table. So it's chi, not chai, chi rhymes with guy. Chi-square table. So there's one in files. There's also a link to it above. Okay, problem number 1, it wants 90% confidence, and n is equal to 11. We're pretty familiar from using T that whenever they ask for a degrees of freedom, it's going to be 1 less. So our degrees of freedom is 10. A picture should pop up in a second. So on my little sheet, I'm going to be stuck in row 10. On my chi-square table, I'm stuck in row 10. And then up top, you'll see that there's a bunch of different areas. 005, 01, 0.025, 0.05. So here's how the chi-squared works. Remember, the z table goes from negative infinity to positive infinity. I like drawing my chi-squared sort of in the axis looking like this because it does not go into the negative. So it starts at 0, kind of goes up, and it goes out like that. It does not go forever to the left. The z table does go forever to the left. So this location right here is 0, and it goes forever that way. Okay, 90% confidence. So that means 90% in the middle. Okay, this is familiar. So 90% in the middle, that's 10% left over. So 5% here, 5% here. And this is when it gets a little bit tricky. Our chi-square table is actually, it's a weird right tail table. So you'll see that when they're pointing at this area on your little chi-square table at the very bottom, it says that that's alpha. So it's coming from the right. So how do I need to get to this location and this location? So if I go from here to here, I've covered 0.05. And if I go from here to here, how much did I actually cover? The 0.05 and the 90%. So this is going to be 0.95. A little weird. So to get from here to here, I went through 5%. And to get from here to here, I went through the 5% and the 95 and the 90, which is 95. So you're going to see that that corresponds. You're stuck in row 10. So sometimes I like to use a ruler. I'm stuck in row 10 and I'm looking for 90% in the middle. So that's going to give me 18.307 and 3.940. So once again, df of 10, 05, 18.307, 18.307, and then 95 would be 3.940, 3.940. And so they said, find the critical values. Okay, so they said the chi-squared 1 minus alpha over 2 and the chi-squared alpha over 2. So if you put 90% in the middle, that means there's 10% left over. 5% here, 5% here. So the 5% on the right, this 0.05 is technically our alpha over 2. So this 18.307 is technically our chi-squared alpha over 2. And then when we went all the way over here, the 5 and the 90 giving us 95, that's technically our 1 minus alpha over 2. So our chi-squared of 1 minus alpha over 2 is equal to this 3.940. And those are our answers. I feel like I over-explained that. Okay, great.